All right, you're welcome again. We want to look at Pearson correlation. This Pearson correlation is actually a parametric test, and it's used to test the dependency of one variable over the other. Now we're going to be using the same data set we have used before under regression. We're going to use the datarium, so we just load this data set and use with the library here. All right. So don't mind, I already loaded before, that's why it's giving me that error. So don't worry. Then we want to evaluate the impact of advertising budget of three media on YouTube. If you just say that's what the data set is all about. So if you glimpse again, you have done before, so you can see YouTube, Facebook, newspaper sales here. Says our y-axis, right? Why this is our s-axis, all right? Don't forget, you can have one or two or more. So I even plot, if possible, plot some for this study. You can plot their 3D view to see them on their spread. Okay, so if you look at the head, maybe just few numbers, 6 rows. You can see for YouTube, Facebook, newspaper, and sales. So look at the structure. So let's attach the marketing here. We already attached before, so that's why it's giving me that error. So now we want to a Pearson correlation actually measure a linear dependency between two variables, x and y. Okay, it's also known as a parametric correlation test because it depends on the distribution of the data. So you need to be to meet the parametric assumptions. That's what it means. Okay, so but we don't need to go into all those details now because of time. So we have done that several times in the past. So I think you should be able to understand that. So in case your data does not meet the assumption, you can switch over to non-parametric. All right, so let's say we want to test if there is a relationship between two or more numerical variables. That is what it's all about. If there is any relationship, if they are related. Okay, that's the purpose of the test. So maybe you can develop your hypothesis Q naught, which is a null hypothesis. There is no relationship between the variable. That is a Q naught, H naught rather. Maybe H1 is alternative. There is a relationship between the variable. There is a relationship. All right. So if the significant, I mean there is a relationship. If not significant, no relationship. So you understand what I'm saying? Let's say we have a H naught, for example. That is what I'm saying. H naught. All right. Yeah, there is no relationship between we want to do between sales and YouTube. Okay, let's say we want to do for YouTube, right? Okay, that is H naught, but let's say we want to have H1, their risk relationship between YouTube, this is YouTube. Okay, right. So mean this means there is relationship. The one there's no relationship, this one there's relationship. So if significant now, right, that means we reject a H naught, we reject null hypothesis. I say there's no relationship. That's what it means. If not, then we reject a alternative hypothesis. All right, so that is what it means. So correlation coefficients is comprised. We have what is called correlation coefficients when we are dealing with a correlation. Basically, it is comprised of between -1 and +1. Okay, -1 indicates a strong negative relationship correlation. That means they are strongly negatively correlated. That's what it means. And the y1 indicates a strong positive correlation. They are strongly positively correlated. That's what it means. So this means that y increases with x. As s is increasing, y is increasing in the graph. So that's what it means. So Pearson correlation between YouTube and sales can be drawn. Now let's say we want to test now. The test is called power test. Okay, we're passing our YouTube here. Why we are doing that? Because we've already attached our this thing, so we can pass it directly here. Our YouTube here, our sales here. Okay, our method is called Pearson. Okay, so we just Pearson here, we just put the method here to show that this is parametric. All right, so when we run this line of test now, we run this, we have this result. Look at it. Okay, so this is our result. We have our T is 17, our degree of freedom, our p-value is highly significant. Alternative hypothesis, true correlation is not equal to 0, which means there is a correlation. That's what it means. We have 95% in lower bound, upper bound. Our estimate correlation is 0.78. That is 78%. All right. Let's say we have our correlation coefficient. That is our estimate now. This one is 0.78. 0.78 is very close to 1. Is that correct? Very close to 1. So this is a strongly positively correlated, right? Now, what if we change to maybe Facebook here? Let's see. Facebook. Oh, what would be the correlation coefficient here? Will it be higher or lower? Which one is better? Let's see. The higher the correlation coefficient, the better the correlation result. So when we run this, you can see this is 57. Facebook 57 coefficient, which is almost half. So you can see, even though it's significant, yet it's positive as well. But coefficient is lower than that of the YouTube. What of newspaper? Let's say for newspaper, I want to see the coefficient also. Okay, let's see. What will be the result? Oh, this is so poor. This is even though it's significant 0.001 and it's also positive, even though it's smaller, yet the coefficient is 0.22, that's 22%. It's too poor. So you can, that is the field. It's not even less than 50%. So the paper is not the best. It's not well correlated with sales. That's what it means. So what it's trying to tell us that there's no strong relationship between the sales and the newspaper. That's what it means. Because it's going lower to more than already less than half, already going to 0. So the correlation is very, very negative. Okay, that's what it means. It's negative correlation. No, it's not. Though it's not negative actually, but it's not strong. That's what it means. It's not strong, but it's not yet minus. Okay, so it's not strong. All right. So this is what they call Pearson correlation between the two. So we can also plot and see their result in the chart. So we can plot. I've already loaded this, so we can just run this. Okay. So we want to see we are part of our marketing here data set. We say we want to YouTube against sales, and we add a regression line to see the line I look like. We also want to have the coefficient method here so that you can see the result. But I want to see the result. That's what I'm trying to do, to see the result together on the plot. That's what I'm trying to do here. So when I run this line now, you can see the result together. Okay, let's look at the result here. R equal to 0.78 for YouTube, p value equal to 2.2. So you can see here, you zoom out. So YouTube advert, our sales in USD. So we have our his coefficient, correlation coefficient here. So we have our p value here. So what if we change to Facebook? Let's say we change to Facebook. We run again. What do we have? So look at it, 58. Look at it. We have 0.58. So it's not, the correlation is not as correlated as the other one. So what if we change to newspaper? What do we have? You can see that is so poor, 0.23. You can see so poor. You can see it's not even supposed to be going vertically up like this, but it's not going. It's going to up, going tends to horizontal direction. You can see it's supposed to be going up like this. So it should be, this one is so poor. All right, so poor. So the one that have highest correlation, is the YouTube with sales. All right, so this is very clear using the test result without even using the charts. The result has already spoken for itself. And see what we got here for each of the test result, correlation test result. This one is very high, 78% or 0.78. It's very high. So that is just a correlation Don't forget for the necessary parametric assumptions should be met before we go further for this. And if not met, then you can switch to Spearman relation, which I will do later as we continue in this lecture. Thank you so much for listening. I will see you in the next class.